Okay, next we're talking about issues related to measurement of variables. Some of this, again, is more research methods than statistics, but we need to understand the basics of it. How a researcher measures a variable has direct consequences on what you can do with that information. What type of statistical analysis can you perform with it? It depends on how you measured it. So let's take a simple example, temperature. If I want to measure the temperature, and I'm going to do it with a regular old thermometer that records degrees Fahrenheit. So I can measure the temperature today and tonight and whatever points in time I want to measure it. And then I've got all kinds of options. I can look for what the range of temperatures might have been. I can do an average, again, this idea of an average, what the average temperature was. But let's say instead, for some bizarre reason in some other universe, I said, I'm going to measure temperature, but I'm going to do it with a survey. And I'm just going to ask people, do you think it's cold, warm, or hot? That is measuring temperature. It's doing it in a kind of a crude way, right? But it's a measurement of temperature. But now, what can I do with that information? I can't compute averages with words, cold, warm, and hot. I can't type that into a calculator and have anything meaningful come out of it. So how we measure variables has a direct impact on what we can do, what type of analysis we can perform. Now, some variables, you don't have a choice. It is what it is. And other variables, the researcher can make a decision, but they've got to make all those decisions before they start their study. So one way of thinking about measurement, a very kind of a simple overview, is thinking about some variables as either discrete variables versus what we call continuous variables. Discrete variables versus continuous variables. So discrete means separate or distinct. So it's different boxes, separate boxes. If you are taking a multiple choice test question and you can pick A, B, C, or D, that's discrete. It's either A, or it's B, or it's C, or it's D. So if we are measuring a variable as a discrete variable, it means our measurements are going to be separate, distinct categories. When we say categories, it's really like measurement options. What the results can be, they're fixed. It's either this or it's that. And there's no in-between value. Again, if we think of a multiple choice test, it's either A, B, C, or D. It can't be A.3 or B.6, or it's this or it's that. If I was doing a thing, what's your favorite color? Red, blue, yellow, green, pink, whatever. Those are discrete options. They are different answers, and there is no real word option between the colors. What kind of car do you drive? Well, I drive a Ford this, or Chevy that, or Toyota this, or Subaru that. That's discrete. Your answer is either I drive this kind of car or I drive that kind of car. You wouldn't say I drive a Ford .372. It doesn't, you can't average together that stuff. So that's discrete. So if we were asking you, well, how many children does somebody have? Well, the answer is either 0, 1, 2, 3, 4, 5, whatever the number is. How many cards do you have? Flip a coin, heads or tails. No one says heads .6. It's either heads or it's tails. Get family game night, get out your Monopoly set, pull out your 6-sided die and roll it. The result is going to be discrete. It's either a 1 or a 2 or a 3 or 4 or 5 or 6. That's discrete. Your answer is either this or it's that, and there is nothing in between. What's your class standing? Well, you're either a freshman, a sophomore, a junior, or a senior. You're either a freshman or a sophomore. There's no answer in between that. It's this or it's that. Continuous, as you might guess, is the opposite. Continuous says that there are a nearly infinite number of values in between categories. So instead of having a no man's land in between there, a void in between there, what it says is there's a nearly infinite number of options in between. I mentioned measuring temperature, cold, warm, hot. That would be discrete. The answer categories are either cold or it's warm or it's hot. There's no in-between boxes. But if I measure temperature with a thermometer in degrees Fahrenheit, that would be continuous. I could measure the temperature in this room and determine that it's 72 degrees. And I could go to a different room and see that it's 73 degrees. Well, those are two different measurements. The question would be, is there any temperature that exists between 72 and 73? Sure, 72.5 degrees is a real thing. Well, is there any temperature that exists between 72 and 72.5? Sure, 72.1. All right, is there any temperature that exists between 72 and 72.1? Yeah, 72.005. Okay, is there any temperature that exists between 72 and 72.005? Yeah, 72.00006. Okay, and see, you can just keep cutting it finer and finer and finer and finer. Your thermometer may not be able to register those fine temperatures, but they exist. So with continuous, there is a nearly infinite number of in-between options. So if we're measuring time, how many minutes or seconds? If we're measuring distance, how many inches, how many meters? If we're measuring weight, how many pounds or kilos? If we're measuring your age, how many years? All those things would be continuous. We can keep finding smaller and smaller answer boxes in between major categories. So that's one way of thinking about our variables that we're going to measure. Is it discrete? Is it continuous? Do I have a choice, like temperature? I can do either one. Is it number of children? Well, I don't really have a choice. It's discrete. It's the only thing it can be. And again, the idea here is it gives us consequences for what we can do with that data later. So next we're going to go to a little bit more fine-grained approach to this same conversation.